Chapter 02. Big Bang Theory, the beginning of the Big Bang idea. The Big Bang Theory is our best explanation for how the universe started. It was first suggested in 1927 by Georges Lemaître, who was both a scientist and a priest from Belgium. Lemaître had an amazing idea. He thought the entire universe began from one tiny, incredibly hot and dense point. He called this starting point the primeval atom, or cosmic egg. Lemaître didn't come up with this idea from nothing. He built on earlier work by other scientists. In 1922, Alexander Friedman had created mathematical models that suggested the universe might be changing size. And then in 1929, Edwin Hubble made an important discovery. He found that galaxies far away from us are moving away from us. This meant the universe was getting bigger over time. Other scientists helped develop the theory further. In the 1940s and 1950s, George Gamow, Ralph Alpher, and Robert Herman worked on the details. They figured out how the early universe's extreme heat would have created the first chemical elements. They also predicted that we should be able to find leftover radiation from the early universe, which we call cosmic microwave background radiation. Interestingly, the name Big Bang was given to the theory by Fred Hoyle. In 1949, Hoyle actually didn't believe in the theory and was trying to criticize it when he used this name. But the name stuck, and now everyone uses it. What the Big Bang Theory says. The Big Bang Theory tells us that our universe started about 13.8 billion years ago. Back then, everything that exists now, all the stars, planets, galaxies, and even space itself was squeezed into an incredibly tiny point called a singularity. This point was unimaginably hot and dense. Then something amazing happened. This singularity began to expand very quickly. Scientists call this rapid expansion cosmic inflation. It's important to understand that this wasn't like a bomb exploding in empty space. Instead, space itself was stretching and growing everywhere at the same time. As the universe expanded, it began to cool down. Incredible energy that was packed into that tiny point started to change into tiny particles like protons, neutrons, and electrons. These are the basic building blocks of all matter. During the first few minutes after the Big Bang, something very important happened. Temperature and conditions were just right for these particles to stick together and form the first simple elements. This process is called nucleosynthesis. Most of what formed was hydrogen and helium, which are the lightest elements. For millions of years after this, the universe was mostly just clouds of hydrogen and helium gas floating in space. But gravity was slowly pulling these clouds together. Eventually, these clouds became dense enough to form the first stars. As more time passed, these stars grouped together to form galaxies, and galaxies grouped together to form the large structures we see in the universe today. The evidence that supports the Big Bang Theory. Scientists don't just believe in the Big Bang Theory because it sounds good. There are several strong pieces of evidence that support it. The universe is expanding. Edwin Hubble's observations in 1929 showed that galaxies are moving away from us. Not only that, but galaxies that are farther away are moving away faster. This is exactly what we would expect if the universe started from a single point and has been expanding ever since. Cosmic microwave background radiation in the 1940s, scientists predicted that if the Big Bang really happened, there should still be some leftover heat from the early universe floating around space. In 1965, two scientists named Arno Penzias and Robert Wilson accidentally discovered this radiation while working with a radio telescope. This cosmic microwave background radiation is like an echo from the Big Bang, now cooled down to just a few degrees above the coldest possible temperature. The right amount of light elements. The Big Bang Theory predicts exactly how much hydrogen, helium, and other light elements should have been created in the early universe. When astronomers look at stars and gas clouds throughout the universe, they find these elements in almost exactly the amounts the theory predicts. Large-scale structure of the universe, the way galaxies are arranged throughout the universe matches what scientists expect based on how matter would have clumped together after the Big Bang. The science behind the theory. The Big Bang Theory is based on solid scientific principles and observations. Mathematical foundation. The theory uses Einstein's general theory of relativity, which describes how gravity affects space and time. Alexander Friedman and Georges Lemaître used Einstein's equations to show that the universe could be expanding. This gave the theory a strong mathematical foundation. Observational evidence, Edwin Hubble's discovery that galaxies are moving away from us, was the first direct proof that the universe is expanding. This observation was crucial because it meant the universe must have been smaller and denser in the past. Physical principles. The theory is based on well-understood physics, including how heat works, how atomic nuclei form, and how particles behave. These principles help explain how the universe changed from a hot, dense state to what we see today. What we still don't know? While the Big Bang Theory explains a lot about our universe, there are still some mysteries. Scientists are still trying to understand dark matter and dark energy, which seem to make up most of the universe but are invisible to us. They're also trying to figure out why there's more matter than antimatter in the universe. Conclusion: the Big Bang Theory, first proposed by Georges Lemaître in 1927 and developed by many other scientists, is our best explanation for how the universe began. It tells us that everything started from an incredibly hot, dense point that expanded and cooled over 13.8 billion years to create everything we see today. The theory is supported by strong evidence, including the expansion of the universe, cosmic microwave background radiation, and the abundance of light elements. Even though some people were skeptical at first, the Big Bang Theory has become the foundation of modern cosmology. It continues to be improved as we make new discoveries and learn more about mysterious things like dark matter and dark energy. The Big Bang Theory doesn't just tell us where we came from. It also inspires us to keep exploring and learning about the amazing universe we live in. Next video. Chapter 03. Steady-state theory explained. Thank you for watching JFSA Tech. Hope you got a clear picture about the Big Bang Theory. If so, please like. Subscribe to watch more videos. Share with other like minds.